Here are the answers for the short answer questions for Monday's lab. So question 27 from the August 2018 Regents. The world's population was 2,560 million people in 1950 and 3,040 million in 1960, and can be modeled by this function P of t, where t is the time in years after 1950. P of t is the population in millions. Determine the average rate of change of P of t in millions of people per year from 4 to 8. Round your answer to the nearest hundredth. Average rate of change is on every single Regents exam. It's asking you for your slope formula, where we're going to do change in y's over the change in x. In this case, your x's are the t's. So x1 is going to be 4, x2 will be 8. So to get the y's to go with them, we are going to plug these numbers in for t in the equation. This will get us our 2 y's, and then we could plug into our slope formula. So plugging in the 4, we get 2,742. Make sure you include the decimal. Remember, we don't want to round too soon. If you still have more math to do in the problem, it means you are not yet ready to round. And plugging in 8, we get this 2,937 number. From here, I can set them up to subtract. Over their x's. I would use my calculator if I were you. Make sure that you're plugging them in the correct order. It says to round to the nearest hundredth, so 2 decimal places, so you should get 48.78. The scores of a recent test taken by 1,200 students had an approximately normal distribution with a mean of 225 and a standard deviation of 18. Determine the number of students who scored between 200 and 245. Normal distribution means we're using our normal curve. The mean goes down the middle, 225. A standard deviation is 18. And we want to see who scored between 200 and 245. So on our calculator, we go to second, VARS, choice 2, says normal CDF. It's going to ask you for your lower, your upper, your mean, and your standard deviation. I need to see this on your paper to get full credit. This is your work. Your lower is the 200, upper 245, mean is 225, standard deviation is 18. So you type that in, go to paste, and hit enter. After you hit paste, yours then looks like what mine just looked like. I get 0.7843. Remember, if there's still math to do, include the whole decimal. So the test was taken by 1,200 students. We want to know the actual number of students who scored between that. So we're then going to take that number multiply by 1200, and we get 941 students. We're not going to keep the decimal. We're talking about students. We're going to go for a whole person, so 941. Question 29. I see fractions with addition and subtraction. I think common denominator. X plus 3 is a binomial, has to show up. And then my monomials, 2, 6, and 2, all go into 6. So I'm going to multiply and figure out what has to get included in each denominator. The first one has the x plus 3. It needs the 6. Whatever I do to the bottom, I'm going to do to the top. So I get negative 18. The next one needs the x plus 3, and it's a 2 that has to become a 6, so it also has to get multiplied by 3. Anything times 1 on that top is itself, so the 3 times x plus 3 comes down. The next one is the 6. It needs the binomial x plus 3. So we have x times x plus 3 on the top, minus, I need to do 3 times x plus 3 again. So it's minus 3 times x plus 3. Lots of distributing now. On the left, I get negative 18 plus 3x plus 9, which is then 3x minus 9 when I combine like terms. On the right, we have x squared plus 3x minus 3x minus 9, which is then x squared minus 9. Those 3x's cancel out. From there, I have something squared, so I set it equal to 0. Subtract the 3x over, add the 9. I get x squared minus 3x, and now my 9's cancel. Factoring, first thing we always look for is a GCF. I can take out an x. I'm left with x minus 3. So then setting each one equal to 0 and continuing to solve, we get x to equal 0 and positive 3. Question 34. Evaluate j of negative 1 given that j of x is equal to this long polynomial. Explain what your answer tells you about x plus 1 as a factor. So starting with finding j of negative 1, I'm going to plug in negative 1 for all the x's, and typing it in, we get 0. So what does that tell us about x plus 1 as a factor? Well, x plus 1 means that x is equal to negative 1, which is what we just found. So x plus 1 is a factor of j of x. And it is a factor because j of negative 1 was equal to 0. Next part, algebraically find the remaining zeros of j of x. So the zeros is what we get when we solve this equation and set it equal to 0. So we are going to have to continue with the question. We know that x plus 1 is one of the factors. That means that x plus 1 goes in to j of x. It divides into it. So to start this off, this original j of x is not factorable, but if I divide it by x plus 1, let's see what we end up with. So dividing by x plus 1, that goes down the side. Highest exponent on top is 4. The bottom's exponent is 1, so it tells me I need 3 lines. So we have 2x to the 4th, negative x cubed, negative 35x squared, positive 16x, and positive 48. Starting in the top left corner, my 2x to the 4th. Top has to be 2x cubed. So 2x cubed times 1 is 2x cubed. Outside minus inside, negative 1x cubed minus 2x cubed is negative 3x cubed. So then that meant that should be a negative 3x squared, which would also put it down here. So now outside minus inside minus negative 3x squared is negative 32x squared. So then we have negative 32x. We want 16x. So outside minus inside gets me 48x. So positive 48. And we already know from the first part that there should be no remainder. So to find the remaining zeros, they are going to come from this new leftover piece that we just got by dividing. So there are 4 terms here, so that means factor by grouping. So I can take out an x squared. I'm left with 2x minus 3. I could take out a negative 16, and I get 2x minus 3. We then have 2x minus 3 with the x squared minus 16. And that x squared minus 16 is dots. These are the rest of the factors. X plus 1, we know from the first part, was one factor. The remaining factors are 2x minus 3, x plus 4, x minus 4. And I now want the zeros. So I'm going to finish setting each one of these equal to 0 to finish solving. And you should get 3/2, negative 4, and positive 4. That one was a 4-point question, definitely a decent amount of work. Next one. Determine to the nearest 10th of a year how long it would take an investment to double at a 3 3/4% interest rate compounded continuously. So compounded continuously is our PERT formula. So while they didn't tell us what the investment was going to be, they did say it was going to double. So you can pick any value as your starting point. Let's say P was 100 that we're starting with. That means our final amount for it to double should be 200. R 3/4 is 0.75. So it was 3 3/4%. So my R is 0.0375. So plugging these numbers into my equation, we're going to solve for T. So no matter what number you picked as your initial amount, when you go to divide it over, it should equal 2 because it doubled. from here, you have your two options. You can either convert this into log bay with your base as the e, or you can ln both sides. Ln of 2, oops, mine went in as a negative. So ln of 2 is 0.6931471806. And it's now equal to the 0.0375t, which we can divide over. And it says to round to the nearest tenth of a year. So you should get 18.5.